Hello, this is the third part of GRASS tutorial. Topics will: using GRASS GIS graphic user interface, layer manager, map display, and terminal, setting computational region and region settings. What is it? Regions in GRASS GIS. Next, we'll have very simple analysis showing an example to show how to use GRASS GIS. Okay, let's start GRASS GIS. Selecting GRASS GIS data database, GRASS superficie 60, GRASS 7 location, and your own map set. When started, there were the three windows. I mean the layer manager, the map display, and the terminal, of course. Now, first, when I want to display a map, raster or vector map, first you have to add it to the layer manager. For example, adding a raster map. Shift-Control-R, of course, can be used as well. Select a map, for example, elevation.dem, digital elevation model from permanent map set. Very well. To zoom in, use plus, or you can scroll, of course, by mouse as well. Minus to zoom out. Right-click on the layer, zoom to selected map, or zoom to selected map, or zoom to the entire area of the map. You may go back in the zoom history, that is very useful. And of course, you can query about you when there is a selected layer, at least one. It is possible to query that layer. Query means querying the coordinates, the value, label if exists, and the color code for the current point. That's very simple, of course. For GRASS GIS, computational region, it is a very important thing in the GRASS GIS. GRASS GIS performs calculations only for computational region. It means you may have a very large map, even a word map as well, a very detailed word map, which could be very large, gigabytes, 10 gigabytes, 100 gigabytes, or whatever. Selecting a small part of that map, that will be the computational region. Now the computations will be performed only for that part of the map. It allows to select only a small part, more than one part of the map, because those are the part of the same map. That's why, of course, those were comparable, and because small regions, relatively small regions, that's why calculation were fast. Even the map itself may be very large. Region means an extent, an area, and a resolution. To set it, set settings, computational region, set region. But first, show current region. Show current region will display the base values, its projection, UTM, zone, datum, and so on, north, south, west, east edges of the map. So the northest, the southest, the westest, and the eastest point edge of the map can be seen here. Resolution, east, west, and SRS, EWRS means north-south resolution, east-west resolution in units of the map. Now, because it is in UTM, Universal Transfer Mercator, which use meters, that's why, of course, resolution is in meters, 100 meter by 100 meter in both directions. User may overrule these settings by setting region, set region menu. When set a region, you can set the region to the entire area of a map, for example, for this raster map. And setting its resolution. Of course, bounds, north, south, east, west, can be set arbitrary. Resolution for north, south, and east-west direction can be set together or separately, different values for north, south, and east-west direction. Normally, we use this resolution. For example, for what value? Okay, what is the resolution of this map? It would be nice to know, because of course each map has its own resolution. When that was created, I mean a raster map was created, of course a resolution had been set for that. Let's see how to get this data. For each map, right click, metadata. Metadata will show that is a cell map, cell data type, integer data, integer numbers, where there are rows and columns and total cells, the projection values, and the resolution. It means 13 meters. 30 meters by default. When the map have been created, this resolution have been set. This resolution was set when this map have been created, and the data range is between these values. The data range. Now we know the metadata of the map, moreover data source, description, comments can be read. So let's set the resolution for 30 meters, because the metadata says that is the best resolution we can have, since that is the original resolution of this map. Run. Now the region is set. Check this. A command is reported. G.region raster Latacunga elevation.dem at permanent resolution Latacunga to 30. It is a command. Actually, this command can be typed in the terminal as well, of course. I can copy it and insert it into the terminal by Shift-Control-V. Now that is a command. It is how to use GRASS commands. Layer Manager, there are menus. For each menu item, for each menu point, there is the command how to use that point. For example, setting computational region, set region, g.region. Typing g.region, g.region, the region setting window can be seen. Typing the parameters, for example, g.region, set raster elevation, set region to that raster map where the resolution is 30 meters. It is a command now. No window will open. The command using these parameters will performed. For each menu, there are the commands. Any menu can be accessed through commands, through that commands, which is there at the menu. Setting region means no, this will, the region for the menu, for the calculation will performed. Launching the City App application. In the settings menu there is set selection, set new selection. That means set computational region in the GRASS GIS. This command is called by the script, which script named set selection, set new selection. When the new selection is set, the computational region will set to that selected region, and each computation will perform only for that, for those items. For example, here I can zoom into the map, selecting this small hill. Now I can name it. I can set computational region extend from display, as it can be seen here, or I can save display geometry to a named region. For example, small no space is allowed. There's a space. Accidentally. Small hill. Okay. Now there is a region which is named a small hill. When I go back to the maximum zoom, I go back to the entire map, I can go back anytime, zoom to a saved region, to small hill. That is now a saved region which can be zoomed or used for calculation. For example, computational region, set current region to small hill. Now that is the calculation region. Calculation will perform all this part for this part of the map. When I zoom out, this red frame shows the computational region. When the user in the city app draw something on the map as for selection, that will save to a GeoJSON file, and that the GeoJSON file can be imported to this map, to this map set. When that is imported, of course, that can be set as computational region boundary. Resolution the same. It is possible to set any resolution. No, the calculation, the computational region is within the red boundaries, and its resolution 35 meters. Of course, it can be overruled any time, so it is possible to go back to set the region to match a raster map, its entire area. And from that point, this is the calculation region. Calculation region, it's very fundamental in GRASS GIS. Let's see a very simple analysis how to use GRASS GIS layer manager. Of course, not only raster but vector maps as well can be seen, can be displayed, can be managed within GRASS GIS by add vector map layer. For example, roads. No, those are the roads. When road is a vector map, its attribute data can be displayed. There are labels, categories. Let's see how to use GRASS GIS for a very simple analysis. For example, converting vector map into raster map. Before converting vector into raster, first have to set the region, because of course the resolution is very important, a very important parameter of this conversion. That's why when the resolution is set to 35 meters, the converted vector after conversion will build up by 35 by 35 meter squares. Manage maps, map type conversions, vector to raster, v to rust, vector to raster, that is the command. Let's convert roads into, for example, roads. It is possible to give the same name, because no, that is another map set. It's my own map set, not the permanent map set. Moreover, vector and raster maps may have the same name because those have a different type. source of raster values, where from to get raster value. For example, its value, let's set 1 for all part. By default, GRASS GIS not overrides the existing map. That's why it is necessary to set allow override. Otherwise, if this map already exists, will not automatically overwritten. Now there is a road raster map. That was the third part. Thank you.